Today we are beginning lesson 6. This is the first part. There are approximately 6 examples that I'll be going through. And you have approximately 8 questions. Practice questions to complete. At the end of this lesson, you should be able to complete assignment number 3 for Unit 3. So the 2 main goals for this lesson, the first one is to solve contextual problems modeling by linear function, a continuation of lesson 5, but we are looking at a variety of questions, and to solve contextual problems involving characteristics of quadratic function. Now, we may begin this part in this unit, but the next unit, Unit 4, will be focusing on quadratic function. But for this part, we will be looking at linear function. So I'll leave quadratic function for the next unit, but I'll introduce it in this lesson. So most of the questions we'll be doing will be based on linear functions. So we will not focus on any quadratic function. But I'll introduce it in this unit. So let's look at the first example. Now, before I go into the first example, you'll be asked to complete questions 1 and 2 for assignment 6. That will be your assignment. And I'll state it on the blog also. Let's zoom out so you can see the questions a little bit in detail. So as before, you'll need your graphing calculator. Let's get it there. Or Desmos. Okay. And just to help guide you, maybe your calculator instruction sheets for the graphing calculator or for Desmos. Let's look at the first question. We'll complete 2 questions in today's lesson. And then you'll have a chance to practice 2 questions. So we'll put together all of the skills you've learned so far in this unit, or in this lesson. So here, example 1, linear application with equation given. So when we have an equation given, there are some questions where the equation is not given, but for the first 2, the equations are given. The next lessons, example 4 and 5, the equations are not given, but they're given a set of values. Let's look at the first one here, where the equation is given. Maya is making necklaces for a craft fair. It cost her $2.50 to make each necklace, and she needs to pay $49 to rent a table at the craft fair. The situation is modeled by the following equation. So we have C is equal to 2.5n plus 49. Now, as we've done before, we can translate this into y is equal to 2.5x plus 49. So now it looks like a familiar equation. Now, n represents the number of necklaces, and c represents the cost. So the c now becomes your y. Okay, so we can go ahead right away and call this is your y-axis, and this is your x-axis. But we'll change that. This would be your c, and this would be your n. So we change. This is the easiest way of trying to understand where you will put your x and y. Okay, n. So C represents cost. So here we have total cost. And that's in dollars. And the n represents the number of necklaces, right? Put this a little lower so I get some space to put my values. Number of necklaces. Now, start from 0 here. So remember, that's your domain, and the range will start from beginning here. Just to remind you, right, your domain would be from your X value here. So this would be your N, and for some other reason, because I want to erase. Let's try a different eraser. Okay, total cost. Now notice that's my y-intercept 49. And this graph is increasing, so now it's going upwards. Because the slope here is positive. Now we have 49, so number of necklaces now will range. So we don't know what the graph range will look like, or what domain, but I'm gonna do an estimate that the total cost, because initial cost is $49. So let's make this 10 here, going up by increment of 10. This is in dollars. Number of necklaces, I'm just guessing. I'll put maybe increment of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this goes on. Okay. It can go on forever. We don't know. It all depends how much she will make. What we'll do next, we will go to our calculator now and enter. Okay, we'll zoom out here. The equation given. So here's my equation given here, which is C is equal to 2.5 n plus 49, which is y is equal to, I'll highlight this here, sequence this here. Y is equal to 2.5x plus 49. So I'll go to now you may want to reset your calculator, but you don't need to. You can go to your Y button, and I'll change that equation. Press clear. By pressing clear, I'm clearing that equation I had before. Now I'll put 2.5x plus 49. Now look at my scale here, right? My scale going up by 1 here and going up here by increment of 10. So, but I want to get my window minimum of 0 and going up to, I'll make it minimum of 12 at least, but let's play around with that number. My 0, I have 200, maybe 200 might be too much, but let's try 100. Let's actually make 100 necklaces. The cost now might be from 0. Notice I minimum is 0, my range here. I'll make that, do I have here? I have 160, make it 200. My graph. So there, what's my graph will look like? So you can tell now it's increasing. Now what's my y-intercept? My y-intercept, I can tell it's 49, but I'm going to prove that. I'll let 0 is 49. So I'm going to make my y-intercept, which is right close to 50 here. And this graph is going up. So now I have my windows set at 100. So I could maybe increase this to maybe make this maybe 10, 20. So maybe these numbers need to change. So that's why it's good to use pencil. So I'm going to use here maybe 25, 50. So I'm going to increment of 25. So it'll give me enough necklaces for her. And here I may have to go up a little bit higher, much greater than the values here. So I can have here 25, 50, 75, 100, 125. Now I'm going to make this a little bit much neater. I'm going to make this, so I'm going to make this 50, 100, 150, 200. 250, 300. Now, I'm not making this equal increment here. 100, 150, 200, 250, 300, 350, 400. So I'm going up increment of 50, and I can do the same thing here because I need my increment to be much higher. So, and now I can leave it as it is here, but my graph will be a little bit more custard. Let's see what happens if I change my window now to 500. And my maximum is 200. It's pretty sharp. So I may have to increase my window, my range. My range here. Maybe to 600. And that'll give me a much nicer graph here. So now what I can do, now I'll get my ruler, and my graph is going up approximately. This is my sketch. Remember, now I put an arrowhead here, meaning that this graph is going up. So it depends on the number of necklaces Maya makes. Okay, so that's my cost. Now here's the question. Find Maya's total cost if she plans to make 200 necklaces. Now, if you want to make 200 necklaces here, how much would it be? Now, I didn't do a realistic scale here, so I'm just doing a sketch here. All right. So now I have to go to my graph here, and this is what you'll have to do in the case. You want to find when the 200 necklaces, how much cost would it be? So to do that, you need to find your determine the y value. Okay, so you're finding the y value. That's what we're given the x value in this case here. We're given the x value as 200. So the x value, so I'll write it here. X value equals 200. What is the y value? That's what we need to find for this here. Now, you could have done it algebraically. You can let n be 200 and solve it. I'll do that also, but I'll do it graphically first. On your graphing calculator, if you follow the instructions here, we'll follow this instruction here. Find the y value. We already have our equation in there. Okay. Now, what we need to do now, we know our x value. So we press your second and trace. That's here. Second and trace. Now, whatever our x value is, okay, we press enter. Whatever my x value is given, in this case, it is 200. I'll enter 200 in here and press enter. So $549. So this will give me $549. So if she were to make 200 necklaces, our cost, her cost would be $549. So these are the steps. I'll write it down here. Okay, this graphing calculator. We have our equation first. One enter equation, which we did here. Y is equal to 2.5 x plus 49. Next, we set our window. Which we set our window to be 0 to 500. Okay, so x minimum 0, x maximum now 500. Now I'll go a little bit higher and make that 600. I'll make that 600. So it doesn't really matter. And then we have y minimum 0 or y max 600. Now, sorry, y max should be not 600, could be 300. Oh, I have 550 here, so I might as well use 550. Now, once I have that, here's my graph. If you're interested in domain, it will be from 0 to 550. And your range now is from 49 to 600, or any values you want to construct. Now, I need to find, so you define the cost now. Define the cost. Okay, for making for 200 necklaces. So press your second button. Let's do it here. So second, okay, let's click that. Second trace. Then we press enter. Then where you see where x is, make x be 200. Now that's what x is. X is equal to 200. Y is equal to, that's what we're finding. $200. Then press enter. And the bottom we have here, x is equal to 200, y is equal to 549. So $549. So it will cost Maya $549 to make 200 necklaces. Let's go to Desmos. Let's try Desmos here. With Desmos, we are going to enter our equation. We'll change that. Oops. Back to Desmos. I don't want. So y equals 2.5 x plus 49. Now, there's my graph. It's showing me negative, but I don't need negative. But I want to find when this is your necklaces here. Okay, we want, now we have get another line. This is a little bit more step here. We need another line that tells us what is the X value. Now our X value is 200. So in Desmos, you'll put in here X is equal to 200. And that's your line 200. You tap on it, and that will give you your cost for 200 necklaces, $549. So let's repeat that. Once I enter my equation that's given, I go to the next line and type in now what is the X value. In this case, the number of necklaces represents by the X value. X equals 200. And where these two lines intersect, you tap, and that will give you the amount of the cost for 200 necklaces. If, for example, they wanted maybe 100 necklaces, how much, if you had made 100 necklaces, how much would it cost? It would have cost her $299 because this is the X represent number of necklaces. Now there's a slider here. You can actually move it around and it gives you a different cost. And X is 16, what it is, right? So that's one of the features of Desmos. Let's look at one more question. Example 2. Ahmed starts the week with $165 and spent $8.50 per day. The situation is modeled by the following equation. Notice this is a negative slopes, therefore he's spending money. He's spending $8.50 per day. That's what spending means. That spending is a negative. So then we can translate that into y is equal to 165 minus 8.5x. D, so here's my equation. D, the number of days that pass, and L is the amount of money he has left. So we can translate all of this, right? So we know the D, the L represents your Y, so we can, this is your L, and the D is your X-axis. D represents number of days. So we start from 0, can have negative days, and you can have negative money here. In this case, so we have here amount of money. So we'll do a sketch of the graph. So we have, now what we'll do, we'll go to Desmos in this case here. We'll enter into our calculate Desmos, which is 165 minus 8.5x. And there is our graph. Now my intercepts, now I can tap on them right away, and that gives me my intercepts. So now here is 165 and close to 20 here. So if I put 20 down here, it's around 19.1. So after 19 days, on the 20th day, he has no more money left. So let's do a, I'll make sure I put this right on the dot. Now this is a restricted domain, doesn't unrange. So if I were to look at this in my domain here, just to reiterate what domain is, domain, start from 0 here, square bracket because it touches 0, and it ends at 19.41 approximately, close. The range from 0 and the y-intercept is 165. Okay. There's our sketch. It's all you need for this, right? You have your label L and your D for days. So we're going to write our domain and range in this situation here. We have our domain. We write this here. So domain 0 to 19.41, close. And the range 0 to 165. Now, how much money does Ahmed have after 5 days? So now we have to find, so now if this is x is equal to 5, we need to find y. Okay. So now we go to Desmos. So on Desmos, what you have, so on Desmos, so second line, so we go back to our graph. So second line, we have our equation. Once we have our equation, the second line, so first line we have y is equal to 165 minus 8.5x. We already have that. Second line, let x equals 5. And then find the intercept. So we put here x equals 5. And find where the intercept. So $122.50 among the money left. So Ahmed has $122.50 after 5 days. Now, if you're using the graphing calculator, we go back to here. We have, let me change my equation here. We have 165 minus 8.5x graph. Now notice my window is off. So I'm going to change my window because here I have to set my window. I'll go to 20 for my x. So I'm going to make that maybe 30. And my range, I'll make that 200. So graph. There you have. Now to find your, so x is 5. What is y? So second trace, enter. When x is equal to 5, x equal to 5. Y is equal to 122.50, same process. Let's write this down. So on the graphing calculator, you press second trace. All right. So we have that. So second, once we have equation second trace, check value, right? Press enter. And you have x is equal to 5. And enter. And that will give you your y is equal to 122.50. Now, the next part now, I'll ask you, how much money does Ahmed have after 30 days? Now, your days, here now, we do the same thing now. We're going to do the same in this case. We'll have second trace, use your graphing calculator. Now, what happened? Okay, well, look, we'll see. We know that it will hit at 19. That's your x-intercept. So he has no more money left after the 20th day, right? So if you were to, so we're going to prove that on your graphing calculator. We already did that on Desmos. On Desmos here, You see that there's no more money after this here. Now, if you were to slide it downwards, now you'll find that he has no more money. Right? Beyond here, he has zero money or negative. So enter. Now we have x equals 30. You press enter. So we can do that here when x is equal to 30. What happens? He ends up with negative $90. Well, he doesn't have any money then, right? He can't spend what he doesn't have unless he went to the bank and borrowed money. So in this case here, we go second trace value 30, negative 90. Oh, you didn't see that. Okay, I'll repeat that because it was out of your screen here. I go second trace value, x equal 30, y is equal to negative 90. So we can say here, so y is equal to negative 90. So Ahmed has no money. No money after 20 days. Right, because he had already spent, right? He spent all of his money after 20 days. The last question, when will Ahmed have $100 left? In other words, how or what day? Now here's your y, right? Your y is 100. What is your x? Now it's doing the reverse. So y is equal to 100. What is x? Now we go to Desmos. So now in this case, we have 100. So I'm going to remove that. So I'm going to go here. Y now is 100. In the previous one, we knew x now is 100. 100 here. You tap on there, you would have just over $7 after 100 days. So he would have after 7 days, you would have had $100. So on this 8th day, you would have $100. So you can say after 7 days, so 7. So after 7 days, Ahmed, right, will have $100 left. You have $100 left. Now, on your graphing calculator now, it's a different process. And it's all written here. So what you will do in the graphing calculator, you will enter and go to your y equal button, and your y2, put the value for y. In this case, it is 100. Once you do that, you press graph, you'll see a line y equals 100 comes up. Yes, which is similar to Desmos here. Except in Desmos now, you just have to tap and you'll get your value for x when y is given. So y is 100, x is 7.647. Now with the graphing calculator now, you have to do your intercept, right? Which is this process here, determine the y value. Oh, sorry, determine the x value. Wait. Where's my x value there? Oh, there it is, right below here. My apologies about that. So this is your step, determining the x value. So first step, we have our enter equation of y1, then enter another equation to give them the y value in the equation. The y value is 100. Then I go second trace. Then it says choose 5. So I go to number 5, press enter. And then you press enter 3 times. 1, 2, 3. And that will give you 7.647. And that's how you end up with a man having $100. So your task now is to go to your assignment number 6, and try for practice questions. I'll find it here. Try questions 1 and 2 on page 37 in your booklet. You can go ahead and try these, but tomorrow, or the next lesson, I should say, I'll be covering questions that the data is given, but there's no equation. You have to go and derive that equation. So we're given a description, or we're given the data, and we'll use that data to derive the equation of the straight line. So let's recap today's lesson. Our goal is to solve problems, contextual problems, modeling by linear functions. We're not going to do quadratic yet. So the first 2 questions we're looking at when you're given the equations. Examples 3, we'll be looking at examples where the values are given. Okay, where the equation is not given, will be given the values, and you have to derive the equation. And your task is to complete question 1 and 2 of assignment 6.